Good morning to all. I'm Sumitra, working as an associate professor in Triple Department of R&D Engineering College. And this semester, I'm handling microprocessor and microcontroller for third year Triple students. And now, in this video, I'm going to explain about how an LCD, that is liquid crystal display, can be getting interfaced with the help of microcontroller, that to 8051. So in my last video, I explained you how a keyboard can be getting interfaced using an 8051, and now in this video, I'm going to explain how an LCD can be getting interfaced with a microcontroller. So first of all, what is an LCD? It is one form of output device which with which we can able to display that output, right? With the help of a monitor. We have the LCD in the form of many applications, like even in watches, remotes, and then in when wherever in we have some display devices that is done with the help of LCD in majority, owing to certain advantages, right? So LCD first of all stands for liquid crystal display, and it is having two types, namely the character LCD and the graphic LCD. Mostly character LCD plays a wide variety of applications, and it is mainly used to display the informations, right? So why we are using this LCDs for display purpose in majority means because of the ease of interface and ease to proceed with the documentation work, everything and all. Okay, so the alphanumeric displays can be available in different formats like 1 cross 16 display, 2 cross 16 display, and 4 cross 16 display, where the classification is mainly based on how many rows it can able to provide the display. That is, in case of 1 cross 16 display, it is capable of providing the display in one row with 16 characters, right? So that's what about 1 cross 16. 2 cross 16 means two rows with each row of 16 characters. Then 4 cross 16 means four rows with each row used to represent 16 character. This is how the alphanumeric displays are getting classified. Alphanumeric means it will display the digits as well as the alphabet. So that's why it is known as alphanumeric displays. Okay, so as I mentioned already, a 16 cross 2 LCD crystal can display 32 characters at a time in two rows, which means that in one row, 16 characters, right? That is 16 characters in one row. So each character in the display is of size about 5 cross 7 pixel matrix. This matrix is not going to be the same for all 16 cross 2 modules. This will be vary for different types of different modules. Okay, so now next coming to the pin description of LCD. This LCD will be having 16 pins, and which can be categorized into four different groups, right? Um, so this is the pin description of an LCD, which is having 16 pins. So this 16 total pin can be categorized into four groups, namely the power, then the control signals, then the data, and the display. So like this, we have a four different groups. So coming to the power pin number 1, 2, and 3 are getting connected to the power. Pin number 4, 5, and 6 are connected to the control pin. And pin number 7 to 14 is responsible for data. And the last two pins, that is pin 15 and 16, is responsible for backlight. Okay, let me explain about the pins in details. So as I already mentioned that 1, 2, 3 is for getting connected to the power. Pin 1 is to ground. That is obviously it has to be grounded to or otherwise to 0 volt, and pin 2 is for the supply VDD, and the pin 3 is used for the contrast. We can vary the contrast by connecting this resistor or a potentiometer across pin number 1 and 2, and then from the variable end, the pin number 3 of LCD can be connected. This is connected to the pin number 2, and this is to pin number 1, and whereas the pin number 3 is getting connected to the variable knob of the potentiometer. So by means of adjusting this potentiometer, we can be able to vary the contrast. Okay, so by varying this, we can able to make the display more dark or the text to be darker somewhat. Okay, so in order to achieve variation in the contrast, the pin number 3 must be connected to the center point of a potentiometer. And now pin number 4 is RS. RS is nothing but register select. So now generally the LCD is said to have two types of register, namely the command register and the data register, where both are provided in the DRAM. Okay. So what do you mean by command register means? We need to give certain commands to the LCD, like display cursor or shift the cursor towards right, or clear the LCD. So these are the examples of command. These command words are getting stored in a register called the command register, whereas a data register means we all know that with the help of LCD, we can able to display the numerals as well as the alphabet. If it is an alphabet, then the corresponding ASCII code must be there, right? So that value will be stored in some register. That is nothing but your data register. So by having a control over the pin number 4, which is RS, we can able to select whether a command register is required or a data register is required. So if you need to send a command, then the command register will be selected by setting your RS as 0. If you need to send the data to be displayed on LCD, then you will be setting your RS value as 1, right? So RS equal to 0 indicates the command register we need and for interfacing, and RS is equal to 1 means you need the data register to display the data on the LCD. Then coming to the control pin number 5, which is nothing but read write pin, but in general most of the time will be reading the data, right? So we'll be displaying some data through the LCD, right? So you don't want to perform some read operations and all, you'll be only writing operation in most of the times. So during the time, this pin will be getting connected to the ground, that is read bar write must be kept at 0 uh, in order to write some values to the display device. And coming to the pin number 6, which is nothing but enable pin. So if you are in need to interface an LCD with the microcontroller, then definitely this pin must be enabled by letting a transition from high to low. So the transitions of the enable pin, that is the transitions of the enable pin, are going to act like a clock for the registers in LCD, right? So whenever we are in need to write a data or the command to the LCD, then obviously we have to generate a high to low transition pulse, which in turn enables your enable pin. So then only a LCD can have this transition. So it will able to understand either a read or write operation has to be performed by it. Okay. Then coming to the data pins. So pin number 7 to pin number 17 or the data pins. So we'll be sending the data only through these 8 pins. So if you are in need to transmit only 4-bit data, then we can enable that by achieving only 4-bit mode, and the remaining, if you other times if you are in need to send 8-bit data, all the 8 ports will be, that is all the 8 pins will be in user using condition at that time. Okay, it doesn't have any constraints on the number of pins. Either we can go with the 4-bit mode or the 8-bit mode. Okay. And then coming to the pin 15 and 16, which are known as backlight pins. And this is used for wearing the backlight in the background. That is, backlight is LED in the background. So to control the backlight, we'll be connecting this pin to the positive voltage and pin 16 to the negative voltage. So which in turn light up the LED, right? So always we are need to connect this pin through a resistor. So in order to protect the LED from damage. So this was the summary of the pin description. So pin 1 and 2, 3 are getting connected to the power, which will be getting connected to ground and VCC, and the middle of this 1 and 2 through a potentiometer by having a variation in a contrast. And then RS used to identify whether a command register or data register has to be selected, and read date operation, if it is performed, it should be at logic 0, and if it is at logic 1, a reading mode is enabled, which is not practically involved, which is not used in most of the cases. And by having a transition from high to low to the enable pin, will enable the LCD to start its operation. And data pins or 8 pins starting from pin number 7 to pin number 14. So it will store the data to be displayed. And then the pin number 15 and 16 is responsible for backlighting the power, right? For providing the backlight ground. And then some of the common control instructions available in LCD are LCD on cursor on, the corresponding X code is 0F, and similarly, the clear display screen, whose X code is 01, and return home, whose S code is 02, like decrement cursor, increment cursor, shift display right, shift display left, display on, cursor blinking, force cursor to beginning of the first line, and force cursor to beginning of the second line. Okay, then cursor line 1, position 3, and activate the second line, display of cursor off. So these are all the listed commands which are present in the command register with the corresponding X code. So now there exist certain steps to write a command or data to the LCD. So first, for displaying a character or the data, what is the steps to be followed is, we should make for displaying a character or the data, we should select the register, right? R should be 1, register select should be high, and if you want, then read bar write must be 0, because we need to perform a read bar write operation, so obviously it must be 0. And then we should have a transition from high to low for the enable. right? And then steps to send a command to the LCD. This may be a character or the data. For command means then we should select the command register by letting RS is equal to 0. Again, read by write is equal to 1. And then enable is set to have a transition from high to low. And this is the interfacing diagram which will show how an 8051 is getting connected to the LCD. As I mentioned already, the LCD is said to have a 16 pin where the pin 1 to 3 are getting concerned with the power supply. 1 and 2 are getting connected to the ground and the VCC, and 3 is connected to the variable knob of the potentiometer to adjust the contrast. And 4, 5, 6 are the control signals which are getting connected to the microcontroller. So by enabling this only, we can able to either transfer the data or the command to your microcontroller. And 8 data pins D0 to D7 are getting connected to any one port of the 8051. We all know that there exists some 4 different ports in the 8051. So to any one of the port, we can able to connect the data 8 data bits of LCD. So this is the representation of an LCD display. So we have it in two modes, like common cathode mode and common anode mode. So what do you mean by common cathode means? The negative terminals of all the LCD segments, LED segments are connected to the ground. Common cathode means like A, B, C, D, E, and F. All the negative segments are connected to negative segments of the LED are getting connected to the ground, right? And by enabling one over here, the respective segments will be on, will be glowed. Okay. And then in common anode, all the positive segments are connected together and it is connected to the VCC. By letting 0 over there, we can able to enable the respective segments in order to display. Okay, there exist different segments starting from A to A, B, C, D, E, F, G along with the decimal point. So a detailed interfacing diagram for 8051 with that of a 7 segment LED displays shown over here. And what we have discussed is the microcontroller 8051 with the corresponding ports. And then these are the power supply equipment for 8051. And then the reset has been connected to the crystal oscillator, and all XTAL1 and XTAL2 has been connected to the crystal oscillator. And all these connections will be used for providing the interfacing between a 7 segment LED display and a microcontroller. So in my next video, I'll be explaining you how to write a program using 8051 to interface the LCD display with that of your um, microcontroller. Thank you all.